This is section 722R1, part 1. We're examining the three basic trig ratios, sine, cosine, and tangent. So today, you guys are going to be able to memorize the three basic trig ratios for right triangles, create a trigonometric ratio, and we're going to find the missing side of a right triangle using those trig ratios. So in geometry, we gave the names to sides of a triangle from one of the two acute angles in a right triangle. So for example, and this is a very beautiful right triangle, if I do say so myself, if this is the angle that we're referencing here, that means from this angle, this is the side that's opposite to that angle, and this is the side that's adjacent to that angle. And then the hypotenuse is always going to be opposite of that 90 degrees. So we name those two legs either adjacent or opposite based upon the reference of that angle. So that's the important piece there, is that from the angle, we can label our opposite, adjacent, or hypotenuse. Now, in a technical basis, we can actually come up with 6 different trig ratios. Now, we're just going to focus on 3 of them, but we can actually create 6 different ways to compare those two sides based upon that particular angle. So let's kind of examine that. What if I gave those sides actual values? 5 is the opposite, 12 is the adjacent, 13 is the hypotenuse. So here are the actual 6 different comparisons. I could do opposite to hypotenuse, or adjacent to hypotenuse, or opposite to adjacent. And then if you kind of notice that these 3 are basically the same thing, but they're just reciprocals of the first 3, meaning that we're just doing them backwards. Now, here are the actual values associated with it. For example, the opposite to the hypotenuse, opposite to the hypotenuse. Now, even though I have these values, these actually have names. The first one is the sine value. The second one is the cosine value. The third is the tangent value. Now, the other 3 do have names, but we're not going to focus on that in this lesson. Okay, this is something that we examine a little bit more when we get to pre-calculus. So, to make it easier for us to write it, instead of writing sine of theta or cosine of theta or tangent of theta, this is how we abbreviate them. This is not sin, it's sine of theta. This is not cos, this is cosine of theta. Now, it's important that we remember these. It's important. And there's a mnemonic that helps us remember those first 3 ratios. So, ka, toa. The sine part, so sine is opposite to the hypotenuse. Cosine is adjacent to the hypotenuse, and tangent is opposite to the adjacent. So this piece right here, we got to have that memorized. All of this is important for us to be able to memorize. So let's actually just practice finding some of these trig ratios. So it's asking here, it's saying sine theta. Well, what do we need to do? Well, we have to be able to find the sine ratio. Well, SOHCAHTOA. The sine ratio is the ratio that's opposite to the hypotenuse. Okay, well, here's opposite. Here's the hypotenuse. So the ratio that's going to be opposite to the hypotenuse is 20/29. If I wanted to find the cosine of P, so here's my reference angle. Cosine is adjacent to the hypotenuse. Oh no, well, what happens if I don't have the hypotenuse? Well, we have the Pythagorean theorem to be able to find the missing side. So if I did a squared plus b squared equals c squared, I would get that that's now 17. And so now cosine adjacent to the hypotenuse is going to be 15/17. So just to recap here, if we have missing sides, we could use the Pythagorean theorem to find it. and then we're going to use SOHCAHTOA to be able to find the ratios necessary. Now, what happens if I had a missing side instead? I had enough available information, but I don't have what I need necessarily to be able to, I can't use the Pythagorean theorem here, right? Because I would also need this side to be able to find that. So we can actually set up an equation using our sine, cosine, and tangent ratios to be able to find them. So we look at the available information. From this angle, I know that this is my adjacent and this is my hypotenuse. So using SOHCAHTOA, I know it's going to be my cosine ratio. And so I would enter that into my calculator, or I would first establish the equation. So cosine of the given angle equals adjacent over hypotenuse. Now this is just an equation. We have solved plenty of equations before. So x is in the denominator. How do we get it out of the denominator? Multiply both sides by x. X cosine of 31 equals 20. Is x by itself? No. This is x times cosine of 31, so that means I'd have to divide both sides by cosine 31. So I get x equals 20 over cosine of 31. You would enter that into your calculator and you would get the approximate value of what your angle is. So in this piece right here, finding x, we could actually go in multiple directions here. I could, if I wanted to, use the Pythagorean theorem. Right? I could say, this is a and this is b and this is c, a squared plus b squared equals c squared. That would be a way for me to be able to solve that. I could also, and it might be a little quicker now that we know this, we could set up different trig ratios. From this angle here, this 42, I know that this is going to be the opposite. This is the adjacent, and then this is going to be the hypotenuse. So SOHCAHTOA, whatever equation I want to use to be able to find it, I could say the sine ratio of 42 equals opposite over hypotenuse. I could say the cosine ratio of 42 equals adjacent over hypotenuse. Oh, look at that. The variable that I need isn't in there. That wouldn't work. I could say the tangent of 42 equals opposite over adjacent. Well, it looks like I could use either of those two equations to be able to solve it. You can pick. I'll just choose the sine, multiply both sides by 13. That would be my answer. So that's the exact answer, right? We could put that in our calculator to be able to find an approximation. So let's conclude this lesson. What did we learn today? Well, we talked about the three basic trig ratios, sine, cosine, and tangent, how to basically find what that ratio is using a right triangle. And then in an instance where we have a right triangle and there's missing information, in this instance the side, we could actually find what that missing side is by using one of those three different ratios. And so what are those three different ratios? We have the sine ratio, which is the ratio of opposite to the hypotenuse. We have the cosine ratio, which is adjacent to the hypotenuse. And we have the tangent ratio, which is the ratio of opposite to the adjacent. And we memorize that with SOHCAHTOA. This does conclude our lesson. If you have any other questions, please leave them in the comments.